December 30th, 2025 started like any other day at Starbase, but the scene in the water was anything but ordinary. Out in the turn basin, a barge was nudging through the waves. It wasn't just a boat, it was a 260-foot-long platform. It was 72 feet wide. This deck was built to carry Starship vehicles lying flat on their sides. Think about that for a second. That means moving something taller than a 20-story building across the Gulf safely. Kiko Donchev confirmed the barge just finished its first trial run. He knows space transport better than anyone. Hardware was already aboard. A propellant tank that usually stays on the pad was gliding over the water. This was a huge step for SpaceX. It means getting Starship boosters out of Texas and over to Florida for upcoming launches. And here's the kicker. The barge wasn't even named yet. That's how raw this test was. It was functional, but not polished. That is what made it impressive. Engineers don't often take something unfinished and push it straight into a live trial, but that is how you move fast. The setup was where the real ingenuity showed. This Marmac 31 isn't your typical cargo vessel. It has steel frames built like giant hands to cradle the vehicles. It may look simple, but the engineering challenge was massive. Starships aren't small or light. A super heavy booster is 230 feet tall. It weighs about 3,400,000 pounds. Laying that on its side without it breaking takes precise math. The team had to consider every wave. They had to watch every current and twist of the barge. This is where it gets interesting. They moved a propellant tank first. It wasn't as dramatic as a full booster, but it let engineers test the balance and the cradle tension. The results were almost immediate. The barge handled it perfectly. No unexpected shifts, no alarms. That trial alone proves the concept works. And it wasn't just smooth sailing. The team had to make adjustments mid-route. They tweaked cradles on the fly to stabilize the tank. That's a rare moment where raw problem solving meets real-world stress. 3 months ago, this was just an idea. SpaceX talked about it in September, but nobody had seen it in action until now. Other companies have tried moving rockets by sea before. It often ended in disaster. Heavy structures cracked, cradles failed, delays cost millions of dollars. By contrast, SpaceX used real-time monitoring and adjustable cradles. This is the part most people miss. It's not just moving a rocket, it's keeping it stable across rolling waves for hours. Every small mistake could dent the rocket. It could even spill fuel. But the trial showed the barge could handle at least one vehicle safely, and they are already planning to scale up. They want to move multiple Starships at once. That is efficiency. Here's why it matters more than it sounds. Florida's Kennedy Space Center has limited space. Texas builds the rockets, but launching from only one site limits how many flights you can do. This barge opens the door to multi-site operations. Elon Musk wants Florida launches by the second quarter of 2026. Now there is a clear path forward. One full Starship can carry over 100,000 pounds of cargo to orbit. With this barge, they can move hardware months ahead. That keeps the launch schedule tight. It means more satellites and faster testing. That is the competitive edge SpaceX needs to stay ahead. NASA and other players simply can't match this flexibility. The engineering team had to solve many problems at once. First, they designed cradles to absorb motion from waves. These aren't tiny ripples. Gulf currents are strong enough to sway a building. Then they added tension systems. These are cables and pulleys that adjust weight as the barge shifts. The technology is precise to inches. If they miss by a little, the Starship could lean too far. It could damage the structure or tip over entirely. The trial actually had a near miss. About 30 seconds from docking, a sudden current pushed the barge sideways. An engineer on deck adjusted the cables manually. The tank wobbled, but the system stabilized immediately. That's where real-world mastery becomes clear. Computers alone couldn't fix it. It needed human skill and fast decisions. The Marmac 31 trial outpaces any previous heavy rocket transport attempt. Other companies took multiple tries to get this right. They faced months of delay. In some cases, they even lost the cargo. SpaceX moved a live component the first time with only minor tweaks. That shows system mastery. It shows they know what they are doing. Think about what this says to investors. It's not just a barge, it's a system that works under real conditions. That is the difference between talking about innovation and proving it. This is why people like Donchev post updates from the field. The work is real and can be seen. The timeline for this is aggressive. The barge was spotted on December 30th. The plan is to move full boosters in early 2026. That's less than 3 months from the idea to a live test. Compare that to traditional space timelines. Other companies might spend a year just on weight models. SpaceX had the barge built and working in record time. Every step mattered. A delay of 1 week could cost millions. Instead, they moved fast and kept the schedule. This pace is rare in an industry where months of planning are normal. Horizontal transport isn't just about the barge. It's about reducing risk. Rockets are fragile and expensive. Every flight costs millions of dollars. By moving them flat, engineers reduce the risk of tipping. That can destroy a vehicle. Fuel tanks are dangerous too. Even a minor leak can end a mission. This barge concept lowers those dangers. It is logistics turned into a defense strategy. A successful first trial proves the approach works. It shows they have mastered technical hazards. SpaceX doesn't just build rockets. They build systems for logistics and speed. In the past, Falcon boosters moved vertically on big trailers. That was slow and complex. Starship's size made that impossible. Horizontal transport solves the problem. It makes everything more efficient. If they can move multiple vehicles at once, the advantage grows even more. This isn't a small change, it is transformative. That's why competitors are watching. China has tried moving heavy payloads, but they don't have this level of monitoring. They face delays that others avoid. The trial revealed 3 important things. First, the stability system worked perfectly with the first load. Second, engineers made real-time fixes to prevent tilting. Third, they docked with millimeter precision despite the wind. Each success built more confidence. Now the team can move larger and heavier equipment. Every step is documented. This proves they know how to operate. The financial impact is huge. Every avoided delay saves millions. Traditional transport failures can cost $50 million or more. Avoiding just one accident pays for the barge many times over. Faster transport also means more launches. That means more money from satellites. Investors see that infrastructure that works reduces risk. By the end of the trial, the bigger picture was clear. SpaceX has a path for multi-site operations. Texas builds. Florida launches. Hardware moves between sites without a hitch. This is a strategic spot competitors can't reach easily. NASA and Boeing are still tied to older methods. Those are slower and less flexible. And don't forget the people. The engineers gained real experience with a live barge. That knowledge builds with every test. No paper plan can replace it. The future looks even bigger. There are plans to carry multiple starships at the same time. This isn't just a guess. The designs are ready. The next test will prove the barge can handle the weight of several boosters. That is where mastery turns into dominance. Elon Musk's dream of high launch rates depends on these steps. Each step forward unlocks new powers. Things that used to seem impossible are now happening. Think about those near misses again. During the test, currents almost pushed the barge off course. The crew had to act in 30 seconds. That kind of response is skill and experience working together. It was the difference between success and a disaster. That is the blend of design and competence that defines this program. Competitors rarely get both right. It's one thing to draw a system on paper. It's another to see it work perfectly under pressure. The numbers show the scale of success. SpaceX's barge trial worked on the first try. Other companies took 3 to 5 tries to move smaller loads safely. Older Falcon systems moved 1 booster at a time. This trial handled full Starship hardware in one go. That is a leap forward. The scoreboard favors SpaceX. They have the speed and the risk management. The timeline shows how fast things are moving. December was the first trial. Early 2026 will be full hardware moves. By mid-2026, they will carry multiple vehicles per trip. Other companies would take years to do this. Speed is power in the rocket business. The faster they move, the more they launch. SpaceX keeps improving. Every step is built on the last. Previous horizontal transport failed because of shaky cradles. SpaceX added real-time adjustments. Vertical transport used to cause delays. SpaceX changed the workflow to avoid vertical lifts. Logistics used to be slow. Now they move huge parts across hundreds of miles of sea with precision. This makes the system very strong. Human decisions are key. Engineers reacted to every move. Every fix made the system more reliable. This boosts confidence for future moves. That is where skill meets advantage. It's about people controlling hardware under stress. The system has many layers. Cradle design absorbs waves. Tension cables adjust in real time. The barge hull is reinforced for heavy weight. Navigation uses sensors to stay stable. Each part works on its own and together. It is complex but simple in its goal. That goal is safe transport. The future is clear. With this barge working, SpaceX can launch more starships faster. They can move hardware safely. This creates dominance over traditional players. It is a real advantage you can see. Every milestone leads to more gains. Competitors have to copy this or fall behind. The successful trial proves that ideas can become reality. The barge isn't just a test. It is proof of planning and skill. SpaceX has a tool that speeds up everything. It leads to more launches and reusable ships. By the end of this trial, the meaning was clear. They confirmed a safe way to move massive rockets. The Marmac 31 enables multi-site launches. The story doesn't end here. Each trial adds to their expertise. This one test reshapes how rockets move. December 30th was a look at the future. The barge proved horizontal transport works. The numbers and the problem solving validate the method. Multi-vehicle transport is coming next. Florida launches can happen faster. The path to high-cadence flight is clearer. The edge SpaceX gains is huge. This isn't just a step, it's a leap. It turns what seemed impossible into a daily reality. Every meter traveled confirmed a vision. This matters because it isn't just talk. It is logistics mastery that saves time and money. It is an advantage measured in dollars and capability. The barge could redefine Starship logistics forever, and with more ships moving in 2026, the real impact is just starting. Florida launches look simple from the beach. You see a rocket rise and think it's impressive, but there is a lot more going on. Florida's location is key. The coast lets rockets fly east over the ocean. That is safer. Rockets from Texas can't go straight north or south without crossing towns. That risk blocks some orbits for satellites. Florida avoids that. This makes it a perfect spot for heavy launches. When you combine the Texas building speed with the Florida launch site, you get a system that is hard to beat. The barge is the link between those two places. It makes the whole program faster and cheaper. The competitive race is about numbers. In 2023, SpaceX flew 96 missions. China flew 67 total. Russia flew 19. The Falcon 9 has landed over 250 times. No other rocket has landed once and flown again. The gap is widening. By the time others have a working heavy-lift rocket, Starship will have years of experience. That isn't hype. That is the schedule. It is about the builds, not just the flights. SpaceX moves at a speed that others cannot reach. They build, test, and fly in weeks while others take months. This barge is one more part of that fast-moving machine. It keeps the rockets moving and the launches happening. It is technical mastery at work. The technical mechanics are fascinating. Each booster uses 9 Raptor engines in the first stage. Each engine's power and restart capability are fine-tuned. Sensors and guidance computers keep the flight on target. Any error could ruin a mission. The fuel load is even adjusted for the Florida weather. Precision in fuel affects the speed in orbit. One Starship reused twice reduces the cost by 30%. NASA's SLS costs $4.1 billion per launch. Starship can fly for under $100 million once it is fully working. That cost gap allows for more frequent flights and faster progress. Think about the Mechazilla arms. Each arm is 75 feet long. They have sensors to track the booster as it falls. They adjust in real time. If one arm is too fast, the system fixes it instantly. The timing window is tiny. The catch is precise to under half a second. It is like a world-class pianist hitting every note, but each note weighs 230 tons. Once caught, the arms retract and leave the booster upright. No scaffolding is needed. That is system mastery that engineers once only dreamed about. By the time Booster 16 left Texas, the workflow was perfect. Catch, inspect, barge, offload, fly. Days replaced weeks, months replaced years. Each success built more confidence. Engineers can now plan rotations with precision. Pads are no longer stuck. The fleet becomes a continuous cycle. This is turning the impossible into a daily job. The numbers tell the story. Barge speed is 7 knots. Gulf transit is 3 to 5 days. Booster weight is 230 tons. Pad integration is under a week. Total downtime is roughly 3 weeks. Compare that to NASA moving a shuttle. The difference is clear. The human side is just as important. Teams coordinate cranes, tugboats, and barge engines. Each move needs timing down to seconds. If the rocket sways, engineers have only 30 seconds to react. Sensors beep and hydraulics adjust. One wrong step could tip the booster, but they trained in simulations first. They repeated every move until they knew it by heart. On December 30th, an engineer almost misread a gauge. The tank shifted 3 inches. That could have damaged the deck. They fixed it in real time. That moment alone proved the training was worth it. This approach wasn't just about safety, it also made things faster. Before, shipping tanks to Florida took weeks. Each piece had to be moved vertically and slowly. With the Marmac 31, a booster can be ready for transit in just a few days. That is half the time. SpaceX increased the throughput. For a company wanting many launches a month, this is critical. The barge can handle upper stages too. That makes it twice as useful. SLS barge operations use vertical transport. Boeing relies on trucks and small barges. Their schedules are much longer. SpaceX can move full vehicles in one trip. That saves 4 weeks per trip. The barge is central to the whole strategy. Faster deployment means faster progress to Mars and more Starlink satellites. In the rocket business, time is money. Speed is power. By mid-2026, the barge will make 5 or 6 trips a year. Each trip moves 2 or more vehicles. The gains grow with every mission. The barge is a strategic asset. Competitors can watch, but copying this is hard. The mix of reinforced decks and smart monitoring gives SpaceX a clear lead. This floating platform is now a transport powerhouse. The journey of the Starship barge isn't just about moving metal, it is about changing how we reach space. It turns difficult moves into a reliable routine. Other launch providers spend months moving parts by truck or rail. SpaceX does it in hours. They can move multiple vehicles in 1 week. This keeps the pace of their goals. The vehicle's strength stays solid, proving the method works. It is measurable success. Efficiency and mastery come together here. Each strap and measurement confirms what they already knew. They can do what was once thought impossible. The system is a competitive moat. Few can do this with such speed and precision. The barge design also looks ahead. The skirts can be changed for bigger or heavier vehicles. Sensors can handle worse weather. Stacking can grow to move even more ships. This is foresight built into the engineering. It is strategy through design. SpaceX moves components faster than historical SLS deliveries. NASA took 5 to 7 days for tank delivery. SpaceX does it in 3 to 5 with heavier loads. Older tugs needed more people and were slower. Current moves use fewer people and better timing. You can see the advantage in the numbers. Each trip carries cargo worth tens of millions. A damaged part means expensive repairs and delays. Efficiency reduces those risks. Cost is a part of technical success. A safe and predictable barge is strategic. Every hour saved leads to more savings later. Once a barge goes from Texas to Florida, it sets a template. As Starship gets bigger, future loads will be heavier. The lessons learned now will guide every mission. It is a repeatable system that builds advantages over years. Competitors know that copying this is harder than it looks. Mastery here is both for today and for the future. The sensors track every move. Tugs monitor their thrust. GPS keeps the course exact. They learn from every failure. A minor course fix in 2025 avoided a collision by 30 seconds. That shows real-time problem solving. These moments show why technical oversight is so important. It shows the judgment and teamwork needed for high stakes. Everything about the barge confirms that SpaceX is leading the way in space logistics. They have solved the problem of moving massive rockets. They have turned it into a reliable part of their flight plan. This achievement ensures that the U.S. stays ahead in space for years to come. The next era of space activity is being built on these foundations. Innovation and strategy are creating a lead that few can challenge. In the end, the work done at Florida's launch sites confirms a grand vision. Each launch proves what careful design and site selection can do. This is human ingenuity at its best. The legacy is unfolding, and the next missions will raise the bar even higher. Every detail matters. Florida's trajectory advantages and the barge transport system make sure of that. The barge success validates months of effort and signals the next frontier of operational efficiency.